Can I use the private on a class? No. Can I use private on a method? Yes. Can I use private on a field? Yes. And can I use it on a constructor? Yes. Public can be used on everything. Static. Well, you can't have static classes and you can't have static constructors. I mean, it wouldn't make sense to have a static constructor. What does it mean that a class is static? Final, I can do on everything but constructors. And abstract, I can do on classes and methods. So let's start at the bottom. What does it mean that a class is abstract?
It means you're just...
Somebody? What were you saying?
I said it can't be instantiated.
It can't be instantiated. Okay. So why would I ever be in a situation where I don't want to instantiate, or where I can't instantiate a class?
Because it can have subclasses that would build off of it.
Sure, but why would I not want to instantiate, or why shouldn't I be able to instantiate the class?
Some methods may not be defined.
There was a method that couldn't be defined, right? Well, it may not be defined. I can have an abstract class that has all its methods defined, but I can certainly have one where the body of the method is not given, and I can't instantiate things that don't have bodies. So the reason for why what you said is absolutely right. You don't want it instantiated because you want people to use it by extending it, and that could possibly mean you've got to implement methods that are missing. So basically, a class must be declared abstract if it has any methods that are abstract. What does it mean a method is abstract? Well, it means it doesn't have a body. So if you have a method that doesn't have a body, where the body is just a semicolon, then the class in which it appears must also be abstract. Can I have an abstract field? No, it doesn't make sense to talk about an abstract field, and it certainly doesn't make sense to talk about an abstract constructor either. Okay, so that being said. Final, what does it mean that a class is final? It can't be extended. What does it mean that a method is final? It can't be re-implemented. What does it mean that a field is final? Can't be changed. And it doesn't make any sense to talk about final constructors. What does it mean that a class is, well, you don't have that. What does it mean that a method is static? The static one here is by far the most complicated one. The other ones are just trivial little checks that we just have to do. Static one we actually have to think a little bit about. So what does it mean that it's static?
Static means that it's a method that can be used, but just by calling class dot in the method name. You don't have to actually have an object of it.
Right, and it ought to be used, and it ought to be called that way. People who call static methods through object or something make their code confusing. If a static method, and I actually think if you use Eclipse, it will tell you, oh, maybe you should change this to the class name, because that's the right way to do it. So there's no object context required for static methods, which also means that a static method can only refer to other static things because there is no object context. You can't refer to a non-static field. Make sense? What about a static field then? Well, static fields live in the class. They're class fields. There's just one instance of them, and it belongs to the class, so it's shared between all the instances of that class. All right. Public and private. I think the definitions of what public and private mean for Espresso is a little bit more, or it's a lot simpler than what it means for Java. And basically, if you don't declare something private in Espresso, it is public. That's not the case in Java. If you don't put a modifier on, it becomes protected. And that has to do with visibility within the package. We don't have packages here, so either you can see it or you can't. Either it's private or it's public. So what does something mean that it's a public class? Well, it can be used anywhere. And since the default is public, if you don't put private and you can't put private, that means classes can be seen anywhere. What does it mean that a method is public? Well, it means it can be accessed through object.method name for anybody holding a reference to an object based on the class in which the method lives. What does it mean that the method is private? Well, it means that you have to be, your object context has to be an instance of the class in which the method lives or a subclass thereof. Same thing with fields and constructors. So private constructors can only be called through a this call or a super call. Can it be called through a super call? They can definitely be called through this call. So that's basically it. Now let's skip. I want to skip the static versus non-static, come back to that in a second, and just do all the easy ones first. So the final modifier, so as I said, the final modifier can be used on classes, methods, and fields, and a final class cannot be subclassed, already knew that. A final method cannot be re-implemented, and a final field cannot be reassigned. A final field can only be assigned once by initializing it at declaration time, which is required. Fields and interfaces should be made final automatically, and thus also require an initializer. So I've actually made a list of things to check. So if you can check all these things off in your implementation, you should be good to go. So we have to make sure that classes that are declared final cannot be extended in a class decal. So how do we do that? Well, if I'm in a visit class decal and I extend something, then go grab that something out of the class list and make sure that it's not declared final. Okay, since final fields cannot be reassigned, they must be initialized at declaration time. So go visit you can see these are the names of the places you have to check things. So in the field decal, if I have a final field, better make sure that it has an initializer. In an assignment, if a final field cannot be reassigned, and the same is true for unary, post-unary, pre-expression. So if I'm assigning to something that is a field, better make sure that that field is not final. How do I know if I'm assigning to something that's a field? Well, the left-hand side in an assignment has a myDecal. That myDecal, if it's an instance of a field field decal, then you can check it there. Same with the unary pre's. A method declaration representing the implementation of a method is only legal if the method is not already declared final in the superclass. So once I have a method decal, go look in the superclass. You can actually use the find method call from phase 4 on the superclasses all methods, and if you get something back, then you know to check to see whether it's final. So they're just those 4 things. What about the abstract modifier? Applied to methods and classes. If methods do not have, if a method doesn't have a body, it must be declared abstract, and if a class contains a method that doesn't have a body, it must also be declared abstract. So if a method decal does not have a body, it should be declared abstract. If a method is abstract, then the class it appears in must also be abstract. And an abstract method cannot be final because it doesn't have a body. If it's final, you can't re-implement it. And nor can a method in an interface. An abstract class cannot be instantiated, so if you're trying to new a class that's abstract, that's bad. And an abstract method cannot be static either. So those are they're not complicated things to check, and it sort of tells you here in most situations where to do the check. Private and public. Things to check. The modifier private and the modifier public are opposites, so you can't have both of them. I don't think you have to check that. I think actually, if you look in the modifier.java, it does that for you. Everything can be declared public or private except for classes. They can only be public. When something is declared public, it can be accessed from anywhere. And when something is declared private, the rules are a little more stringent. So private methods can only be accessed from within the same class as they're defined. Is that true? Can I access private methods in my superclass? Probably not. At least that's what it should. In the superclass.
Not in the super, you shouldn't be able to.
Well, this says you can't. So you have to be of the same class, and private constructors may only be called by methods or other constructors within the class. That is, they cannot be invoked through a call to new, and private fields can only be accessed from within the class as well. The private and the public modifiers cannot be combined, and if neither is specified, we assume that the class method constructor or field is public. What to do? An explicit constructor invocation, invocation through the super keyword, cannot access a private constructor in the superclass. So you can't say super something if the target constructor in the superclass is declared private. When accessing fields through a field ref, private fields can only be accessed if the target of the field reference is of the same type, which is a class type, as that of the context. So you can ask the context, what's your class name? You can ask the field ref, what's the class of your target type? We know that because we did that in phase 4. An invocation of a private method is only legal if the current context is the same type as the method being invoked. Same thing, we just talked about the fields. Field references without a target, which we remember are represented by a name expression. And again, if the name expression represents a field reference to a field in a superclass, then that field should be declared public. So in other words, I cannot access private fields in the superclass there either. And when instantiating a class, then the constructor that we end up calling cannot be private either. See, this was originally all sort of woven into phase 4, and it was a little bit of a mess, and it's a lot easier to do the way it is now, because you don't have to worry about the types. And that's pretty much it. Not talking about the static and non-static thing. So let's do that, and that actually requires a little bit more thinking. And I sort of wish this was on the same page, but if you flip your assignment to page 45, then I'll flip this one to 46, and we can look at it that way. So if you see here, I have a class that has a static field I and a non-static field j. That means the static field I is associated with the class. There's only one instance of it, and it's shared between all instances of A. Every instance of A, i.e. every object based on A, gets its own copy of J. Here's a method which is static, returns nothing, and it's called f, and it does the following. It says I to 9 and j to 10, and then I have a g method which says I to 11 and j to 12. And then I have a h method which creates a new a and then calls f on object.f and class.f and g the same way. Now, how much of this is legal and how much of it is illegal? Well, let's start at the top. Can I in a, I'm going to go back here. Can I in a static method well, I can't remember, was I the non-static one? No, static. I is the static one, so let me write it down here. It's static int I and int j.
So the static f function f can mess with I, but it can't mess with j.
So the static method can only refer to other static things, you're right. So it may assign and read I, but it certainly can't touch j because j is a non-static field. Non-static fields live in objects, and static methods do not have an object context. Fair enough. What about G? Huh?
Can't touch I.
Sure can. Non-static methods can access static stuff as well.
But they can't, it will throw you an error saying that you're trying to modify the static field.
You're allowed to modify static fields. It's not final.
It's not final.
Yeah.
Sorry.
So that's perfectly fine. I can access I as a static variable inside a non-static context, no problem. And of course I can access j because it's a non-static field, so no problem there. Can I say object.f
I don't know.
here?
You can, but not preferred.
Right, we certainly can, but it is not the right way to do it because when I look at that, I can't see that that call is a call to a static method. If I look at it this way, I can certainly see that it's a call to a static method. That's perfectly fine. And that is a call to a non-static method on an object context. That's also fine. Oops, here's a call to a non-static method on a static context. That isn't going to work either. So legal, not very nice. Legal, legal, and illegal. Now, if you look at what it says below, it says, well, wait a minute. Why can I not do why can't I do this one here? You go down here, it says, no, we know we can't do this one here because there's no object context. But why, when I do a.f here, which is legal, not preferred, why can't I access this I? Because, sorry, this j. J is a non-static field that lives in an object. There's the object in which it lives, and I'm calling f. So why shouldn't this be legal? It's all there. Well, yes, however, when I'm compiling, translating the code for f, I don't know that it's going to be called with object.something because a static method really ought to be called like that, but maybe called like this. So when I'm just looking at that code and not looking at any of the surroundings, I can't be guaranteed that there will be an object context. So the rules are simple. Static methods may only refer to other static methods or static fields. Non-static methods may refer to anything. And I think one of the first things people get confused about when they start programming Java is the following. Main has to be static. If static methods can only refer to other static methods, how the hell do I get out of this sort of static environment and into something that is non-static? And the answer is this. You provide an object context, and invoke a non-static method on it. Now you've lifted yourself out of this sort of static world, right? So this is the one that does it. By providing a non-static context here, I can now call non-static methods, and I'm off. So what sort of checking do we have to do? Well, so here's the explanation of the current context that we just went through over there, and we set it in the exact same places. There's also this left-hand side thing which I'll talk about in just a second. But so here are some of the things that we need to check with respect to static versus non-static. So references of non-static fields through a field reference like class.field is legal. So if I have a field ref where the target of course is always of class type. But if it's of class type and it is a name expression that is the name of a class, then that field better be static. Okay, if a method declaration is re-implemented, is a re-implementation of a static method without declaring it static, then we can't do it. So if you have a static method in your superclass and you want to re-implement it, you got to give it the same modifier. It has to be static. If you have a non-static method, you've got to implement that one, re-implement that one as a non-static method as well. So you can switch between the two when you re-implement methods. We don't have to worry about fields because we can't re-implement fields at all. And an invocation of a non-static method from a static context is illegal. So an invocation of a non-static method from a static, that was the a.g, the very last one. That one just is not going to fly. And the reference of a non-static field through a name expression in a static context is also illegal. What does that mean? So it's a situation where I have a field reference without a target. They're always name expressions. But if that represents, well, how do I know if that name expression is actually a field reference?
Talking about in general or in Espresso?
Espresso. Well, in real, what we really ought to do is we really ought to, when we find out that name expression is a field ref, we really ought to replace it by a field ref with a null target. But we don't have any easy way of rewriting the tree. But it would be nice if we did that, because the target is never null in a field ref, because if it were, it would become a name expression. So, but look at the MyDecal, right? The MyDecal of a name expression points to a field decal if we're dealing with a field reference. So if my name expression of MyDecal is a field decal, then it better not reference a non-static field in a static context. And references like super.field or super.method and this.field or this.method are illegal from static context. Okay, how do I know if I'm in a static context?
Or keeping track of the current context?
We keep track of the current context, and it just happens to be that anything that implements class body decal can answer the question, are you static? It has a method that does that for you. So you can always ask a context, are you static? Well, that's very convenient, because that is exactly what we need. And then there's that one thing, it says the variable left-hand side, which should be true when visiting the left-hand side of an assignment. This makes it easy for you to check if you are reassigning to a final field. So if you're on the left-hand side of an assignment, you set left-hand side to true, go visit the left-hand side, and then when you come out, you set it back to what it was before. So you have to keep track of what the old left-hand side was, set left-hand side to true, go visit the left-hand side, set left-hand side back to what it was before you started, because you can have many assignments nested. Which means that when you visit a name expression and you have a field, and you are on the left-hand side, because left-hand side is true, then that field better not be final. So that's just an easy way to make sure that we're not assigning to final fields. And that's it. So a bunch of little checks, nothing complicated. This static stuff is by far the most complicated, so it's something you actually need to have a good grasp of if you want to do OO programming anyways. So wrap your head around that and get this done by Wednesday next week. And we're almost done. Yes? Everybody happy?
Good question.
Why? So if you hold on just a second. No, never mind. Any questions?